Hi guys, welcome back to Mathematics for Engineering 3 for students at Kasetsart University International Program. Today we are going to talk about Bernoulli Equation. Okay, so in the previous section we talked about the linear equation of order 1, right? And today is going to be Bernoulli Equation. So first, let's have a look at the form. So the Bernoulli equation is a first order ODE of the form. So it's of this form. It's not linear, right? It's not linear. Why? Because here you have y to the n, right? Sorry, here is dependent variable y, and here is dependent variable x. Sorry, it's y to the n. So because we have this guy, so it's not linear first order equation, right? It's not the same as in the previous section. If I just delete this, I'll recover what we did in the previous section, which is the linear equation of order 1, right? And similarly for the case when x is dependent, if I delete this part, we're gonna get the linear equation. So if n equals 1, you can see that these equation star, they become separable, right? Because if n is 1, you can just push it there and then you pull y out, right? And then you divide the whole equation by y, so it becomes separable. Here as well, you put it that way and then you pull x out and then you divide the whole equation by x. You can try it yourself, okay? You're gonna get a separable equation. So we can look at the case when n is not 1, okay? Because if n is 1, it's separable. And if n is 0, again, if n is 0, it means that this disappeared, which means that it becomes a linear equation in its standard form, the one that we looked in the previous video, okay? So how to solve the Bernoulli equation? Let's look at the way. So first I'll just delete the n in out, so it dependent y, okay? So when y is dependent, first we're gonna divide the whole equation by y to the power of minus n, okay, just to get rid of y to the n, okay? So we have this. Make sense? Make sense? And then we let z be y to the power of 1 minus n. So dz is actually 1 minus n y to the 1 minus n minus 1, right? You push this down is 1 minus n. So the exponent of y is 1 minus n minus 1, which is minus n dy. So we have that dy is actually 1 over 1 minus n y to the n dz, right? You just move this guy to this side, so we have dy, okay? And then we substitute dy in there. Oops, sorry, dy in there, okay? So this is what we have. We have y to the power of minus n, and then dy is actually these guys, right? So we put it here, and then px, and then because z is y to the power of 1 minus n, so we have z here, and then we have dx, qx dx, okay? And after that we have, these cancel out, y to the power of minus n and y to the power of n, they are cancel out, right? The multiplication of them is just 1, okay? So we have this, and then we multiply the whole equation by 1 minus n, so this is what we have. And guys, it becomes a linear equation, right? We have z, we have dz, and here is only x, and here is only x. So it becomes a linear equation when z is a dependent variable. Okay, so it becomes a linear equation. So what is mu? Mu would be just e to the power of integrate things in front of z, right? Right, we did that in the previous video, right? So it's e to the integrate of 1 minus n px dx. Okay, and then we multiply mu back to this equation, right? And after that we find the d mu, right? And after that we rearrange the term, and when we get the solution, don't forget to substitute z back, z which is y to the power of 1 minus n back into the equation. Okay, so guys, if you are familiar with the linear equation, it's done here, right? You know how to go further, right, from the previous video. Okay, so let's look at when x is a dependent variable. So first, the same guys, I'll divide the whole equation by x to the n. Okay, so I divide the whole equation by x to the n. After that, I let z be 1 to the z be x to the 1 minus n. So that's the value of z, okay? So dz is, what is it? What is dz? Dz would be 1 minus n x to the minus n dx, isn't it? So we move this guy to the left hand side. So we have dx is actually this guy. Okay, and then again guys, the same thing, we substitute the x in this equation. So we have this, right? And this guy x to the power of 1 minus n is just z. So we have this equation, and then I multiply the whole equation with 1 minus n. Okay, and then this becomes a linear equation again, right? It becomes a linear equation again, and mu is e to the, you know, the things in front of z, right? So the integrating factor would be e to the integrate 1 minus n py dy, and then you multiply mu to this equation, right? Oh, sorry, to this equation, right? And after that, you just rearrange the term integrate throughout the equation, and after that you get the solution. And don't forget guys to substitute x with to substitute z with x to the power of 1 minus n. Okay, because our solution must be in terms of y and x, right? Okay, so guys, the take-home message, again, the take-home message, when we look at the dependent x and dependent y, okay, when we look at dependent x this one is already correct. Okay, this one is already correct. When we look at dependent x, which is in this form, okay, we first divided the whole equation by y to the n, and here is x to the n, right? We divide the whole equation by y to the n and x to the n. And after that, we substitute z by y to the n minus 1. Here, x to the n minus 1. You will see in the exercise, and it will become even clearer. And then we substitute dy with dz, dx with dz, and this equation becomes linear. Okay, and then we have this, right? We can get the integrating factor, right? And then we get the solution, then we substitute back. Okay, I go quite fast in this video because it's 75%, similar to the previous one, okay? The trick is just to substitute here, to divide the whole thing by y to the n, and then substitute y to the 1 minus n with z, and that's it. The rest is the same. Okay, so let's look at this example here. First, I will move this guy up here. Okay, because I look here, guys, I have dy, right? And then I have 1y dx. See? Sorry. Then I have y, which is gonna be from here, dx, and then I have y to the power of 3, right? Right. So what I am going to do is that I'm going to write this in 6. I think I'm gonna move it first. So it's going to be 2x dy plus 6y cubed minus x, let's say plus minus xy minus y. How about this? How about plus y minus x minus 1 dx. And I should have dx here as well, right? Equals 0. Makes sense, guys? First, I move this guy to the front, so I get this. Okay, and then I multiply y in here, so I get 6y cubed dx. Okay, and then here y, I keep it outside, and then I have this guy inside. Okay. Okay. After that, I have 2x dy. Sorry. I have 2x dy. Plus minus x minus 1 y dx equals minus 6y cubed dx. And then I divide the whole thing by 2x. So I get dy plus, can I pull the minus out? I get minus x plus 1 divided by 2x y dx equals minus 3y cubed divided by x dx. So guys, as you can see, I have here the y dy, and I have y cubed. So it is Bernoulli, right? It's Bernoulli equation. Okay. Okay. Oops. Here is x. Okay. It's actually 6. It's actually 6 divided by 2x. Okay. So it's cancelled out. So I have 3 here. 2 is cancelled out. So after that, I need to divide the whole equation star here by y cubed, right? By y cubed. So what I have is y to the power of minus 3 dy. To divide the whole thing by y cubed is the same as to multiply the whole thing by y to the power of minus 3. Okay, minus x plus 1 divided by 2x y to the power of minus 2 dx equals minus 3 divided by x dx. Okay, and then guys, we need this one to be z, right? Right? You know, I don't want you guys to remember that you want to substitute z by, you know, y to the power of 1 minus n. No, I don't want you guys to remember it that way, because it's going to be, you know, harder to memorize. So just be reasonable. If you are reasonable, you know that you want this guy to be z, right? Right? You want that guy to be z because it will be linear in z, right? So it's going to be some x and z and dx and some x, right? And it will be dz by, it will be dz somehow, right? So I let z be y to the power of minus 2x. Okay, okay, okay. So if you want to follow this take-home message, you need to look here. You will have that n is actually 3, and you need to substitute z by y to the power of 1 minus n, which is, oops, sorry, n is 3, so it's gonna be y to the power of minus 2. And that is the same as what I am doing. Okay, but I don't want you guys to follow that rule because it's going to be, you know, too much information to memorize. Okay, so if you just be reasonable, you know that you want this equation to be linear, right, in z. So you need to eliminate y, right? So you need to change this guy to z. Make sense? Make sense? So that it will be x, right? Like px, and then z, and then dx, and then x. Make sense? Make sense? Right? So if z is y to the power of minus 2, we have that. What is dz? Dz would be minus 2y to the power of minus 3 dy. Right? Right? And again, guys, you can see here, minus y dy, minus y to the power of minus 3 dy. So I have that y to the power of minus 3 dy is actually minus 1/2 of dz. Okay? Okay? So I substituted back to this equation. So what I have is, what is it? Minus half of dz, right? Right? I just change this guy to minus half of dz. Okay? Okay? See, I want you guys to do it just like this, right? First, rearrange the equation. Okay? Second, divide the whole thing by y to the power, right? From the right hand side, you divide the whole thing by that one. And after that, third, you look here, right? The thing in front of the x, the second term, you want that to be z. You want that to be z, right? Then you let z be this guy. And then you find dz, right? Fourth, you find dz, which means that you can substitute this as dz. Okay, okay. So what we have here is 1/2 minus 1/2 of dz minus x plus 1 divided by 2x z dx equals minus 3 divided by x dx. See that it's become closer and closer to what we want, right? We just need to eliminate the coefficient of dz, right? So I multiply the whole equation by 2. So what I have is dz minus s plus 1 divided by x z dx equals minus 6 divided by x dx. Okay, sorry, I multiply the whole equation by minus 2. So what I have here must be plus and plus. Okay, my camera is dead. Okay, so I'll be back on camera later in the next 2 minutes. So let wait for me. In the meantime, just look at the screen. Okay. Okay. So right now we have the linear equation, right? So it becomes linear, right? It becomes linear. Okay, let's call it double star. Becomes linear. So as you remember, I would let mu be e to the integrate, and this guy, right, things in the in front of the z to the power of 1. So is integrate of what? X plus 1 divided by x dx. Okay, and that is e to the integrate of 1 plus 1 over x dx, which is e to the x plus log of absolute x, okay, which is e to the log of e to the x plus log of absolute x. Okay, guys, don't forget this log and exponential, they cancel out. Okay, so we have that. It's actually what? E to the log of absolute x e to the x, which is absolute x e to the x. Okay, it's absolute x e to the x. So again, guys, this guy, it can be, x e to the x and minus x e to the x. But as I told you, if you multiply the whole equation by plus or minus, it's the same. So I will just choose mu as x e to the x. Okay, and after that I will multiply mu to double star. Okay, I multiply mu to the equation double star. To make this equation, what is it? Exact. Remember that, right? Okay, and then I'll copy this equation to the next page. And I'll copy the mu as well. So the next step is that I multiply mu. First, I almost forgot. I need to find d mu first, right? What is d mu? What is mu? First, I need to look at the mu here, right? This mu here. I will copy it to the next page as well. That is the mu. Right? As I told you, I won't d mu with this one. It's doable, but it's gonna be much harder to see. So d mu is e to the integrate x plus 1 divided by x dx and x plus 1 divided by x dx. Right? We did this many times in the previous section. So here it's actually what? Mu x plus 1 divided by x dx. Okay. So guys, when I multiply mu to this equation, what I have is mu dz plus mu x plus 1 divided by x z dx plus equals 6 divided by x dx, and I have mu here as well. Okay, and again guys, as what we did before, mu x plus 1 divided by x dx, that is actually d mu. Okay, so what we have is mu dz plus z d mu, which is mu 6 divided by x dx, and that is d of mu z equals mu 6 divided by x dx. Okay, and then I substitute mu with the x e to the x. So I have d of x e to the x z equal x e to the x 6 divided by x dx, and this got cancelled out. Okay, and then I integrate throughout the equation. Okay, so these cancel out, so I have x e to the x z equals 6, the integrate of e to the x is e to the x plus c, and that is the solution. Is it easy? Okay. Okay. Next one. I'll let you do this as again an exercise. Okay. I'll let you do this as an exercise. You can try it yourself and see whether or not you can get the answer. Let me see if I have the solution here. It's Bernoulli, right? 1 second. Yeah, I have it here. The solution is y minus 3 equals to and that is the solution. Okay. Okay. Oh, in the previous question, I forgot the last step. Sorry, I forgot to substitute z back, right? So what I have is x e to the x y to the power of minus 2 equals 6 e to the x plus c. Sorry, this is not the last answer. I need to substitute z by y to the power of minus 2 back into the equation, right into the solution. Sorry, I forgot it. Okay, and this one as well. You can try it, okay? You're gonna get this solution. If not, okay, we can talk about that in the live class, okay? So I'll do another one, okay? And which is to solve this equation, okay? And as you can see, guys, we have y, we have the x here. It seems to be that we have 1x here and x to the power of 1/3, okay? Okay, so I'll just rearrange the term. Y cubed dx plus 9y squared x dy minus 18. Can I move it to the right hand side so it equals 18y to the power of 5 x 1/2 dy. Okay, and then I divide the whole thing by 2y cubed, so I get the x plus 9 divided by 2 y x dy. Okay, oops, sorry, I divide the whole thing by y cubed, so I have y divided by y x dy, right? Because I have y squared up here, I divide it by 2y cubed, so this cancelled. I still have one left here, right? So I have 2 here as well, and here is 6y squared x 1/3 dy. Okay, and this is the first guy that we want to eliminate. Okay, so I divide the whole equation by x to the power of 1/3, which is the same as to multiply the whole equation by x to the power of minus 1/3, right? So what I have is x minus 1/3 dx plus 2 divided by 9 divided by 2y x to the power of minus 1/3 x dy equals to y squared dy, which is x minus 1/3 dx plus, what is it, 9 2y, and here is x to the power of minus 1/3 plus 1, which is minus 1/3 plus 3 divided by 3, which is 2 divided by 3, okay, which is 2/3. Okay, so is 2/3 dy equals 6y squared dy. Okay, okay, and guys, it's only y here, right? It's only y here. We have y here, we have y here as well. So what we want to eliminate is actually this guy, right? We want that guy to be what? To be z, right? We want this guy to be z. Make sense? Let me use some other color. We want this guy to be z, right? So that we have some dz, some y, z, dy, and some y, right? So just use your reason, okay? Just don't memorize all the things. You can't memorize all the things, okay? Otherwise you're gonna your memory is going to be full. Okay, so I let z be x to the power of 2/3. So dz is 2/3 x to the power of minus 1/3. Okay, just minus 1, right? 2/3 minus 1, that's minus 1/3. And we have the x here. So guys, again, see, it's the same pattern. If you keep doing exercises, you will see the pattern. Here is actually the same as here, right? So we have that x minus 1/3 dx is actually 3 divided by 2 dz. Okay, 3 divided by 2 dz. So I substituted back to this equation, right? I substitute this back to this equation. So what I have is, what is it? 3 divided by 2 dz. Okay, let me write it a little better. Guys, when I write 2, it's like that. When I write z, I have one more line here. So that's the difference between 2 and z, okay? So I know it's a tiny different, but still different, okay? So it's 3 divided by 2 dz plus 2y z dy equals 6y squared dy. And after that, I multiply the whole equation by 2/3, okay? I multiply the whole equation by 2/3 because I want to eliminate this guy. Okay, let's just write it. I multiply. I'll call this equation star. I multiply star with 2/3. Okay, so what I have is dz. Okay, 2/3 and 3/2, they cancel out, and I have, what is it, 2/3, so I have 3z dy. Okay, 3 divided by y, sorry, 3 divided by yz dy equals 6y squared dy. Is it? Oops. 1 second. I probably did something wrong. Yeah, here it's 18, guys. It's 18. When I move to this side, I change it to 12. I don't know why I did that. I'm sorry. So let me change it back to 18. Okay, so when this is 18 divided by 2, they will become 9. Okay, and this is still 9 and 9. Okay, and this is still 9. My bad, I'm so sorry. 9. Okay, so if I multiply it by 2/3, what I have would be, what is it? 6, right? 6, and then it becomes 6 y squared dy. Okay, now guys, now we call this equation double star. Now this one is linear, right? We have z, we have dz, and we have the rest are y. So again, guys, the integrating factor is what? E to the things in front of z, right? So it's integrate 3 divided by y dy. Okay, so which is e to the 3 log absolute y, which is you know, we have done that many times, right? So it's e to the log of absolute y cubed, which is log of absolute y cubed. Oh, sorry, which is absolute y cubed. And I can say that I just choose mu equals y cubed, right? Because I don't care about minus or plus, because it's the same. Okay, I choose mu equal y cubed. Okay, so what is d mu? D mu is what? We begin from here, right? From here, right? Oops, sorry. From here, right? So d mu is actually mu 3 divided by y dy. Okay, we did that many times, so I do it very quickly, okay? Okay. So, if we multiply mu, we multiply mu to the equation double star. So, what we have is, what is it? Is mu dz plus mu 3 divided by yz dy equals 6 mu y squared dy. Okay, mu dz plus mu 3 divided by yz dy equals 6 mu y squared dy. But guys, again, we did this like 1,000 times already. Okay, I am exaggerating, but it's many times, okay? So it's mu, this and this, so this become d mu. So we have that this is actually d mu z equals 6 mu y squared dy. Okay, and then I'll copy this to the next page. Okay, but what is our mu, guy? The mu is y cubed, right? Y cubed. So what we have here is d of y cubed z equals 6 y cubed y squared dy, which is 6y to the power of 5 dy. So in that case, if we integrate with plus c, right? This cancel out. So we have that y cubed z equals, what is it? 6y to the 6 divided by 6, right? Plus c, and that's cancel out. Okay, is it? Okay, and then what we have is the solution is y cubed z equals y to the 6 plus c. But guys, don't forget that our z is actually x to the power of 2/3. So what we have here is, what is it? Y cubed x to the power of 2/3 equals y to the 6 plus c, and that is the answer. Okay, so let me sum it up. First, when you're doing this Bernoulli equation, first you rearrange the equation, right? And then you divide the whole equation by y to the power of blah blah blah, or x to the power of blah blah blah, right? So you eliminate this term, right? It's the same for the other equation, right? This one, you divide the whole thing by this one to eliminate this term first, right? After that, you get this equation, right? And you try to substitute this with z, right? To eliminate this, to change this to z, and then you change it to dz. Make sense? We want to make it linear, right? We know that it's going to be linear. Similarly, in the previous one, for this one, right? We have this, we change this to z, right? To have the z here. So we let z be this guy. Okay, and then we find dz, which means that we know that dz is this guy. So this is actually minus half of dz, and then we substitute, right? After that, we get this equation, which is the, what we're familiar with, the linear equation. So the integrating factor is the e to the power of integrate this guy, dx, right? And then you multiply that back to the equation, right? And don't forget, guys, that this one is actually d mu z, right? To make it easier, it's from the previous section. I emphasize that in the previous section, right? And that's it. And then we integrate, we get the solution. And finally, we need to substitute z with, what we did before, right? In order to get the solution in terms of x and y. Okay, and that's it for Bernoulli equation. Okay, I know, guys, it's tough. Okay, it's so many formulas, so many things to remember. But again, I know I keep saying it, I know, but keep doing exercises. Okay, if you have questions, just come and talk to me. I am ready to help. Okay, I'm very happy to help. Okay, so see you in the next video. Okay, bye bye, guys.